Hello, everybody. How are you doing? It's Mourad Sultan Ezouidi, the mathematics teacher. Okay, the professor in mathematics. Today we will try to solve polynomial to the power six. Okay. The previous week we started, let's say, solving polynomial to the power four, and also we solved polynomial to the power five. And today we are going to solve a polynomial to the power six, or a polynomial raised to the power six. Of course, in this example, you are going to learn from new, and you learn, let's say, how can you use the discriminant formula of Mourad Sultan Ezouidi. Okay, let's start, learners. I'll just share the screen, if it is possible, of course, entire screen. Okay, also share system audio. Then we start. Okay. So those who are interested in solving polynomial to the power six, okay, it's an occasion for you to learn from new, sorry, and to learn also from your mathematics teacher, Mourad Sultan Ezouidi. Okay, it's the whole research in the field of mathematics, especially in the algebra, polynomial to the power n. Here, between parentheses, we can solve any polynomial to the power n. Okay, and let's say those who told that it's impossible to solve polynomial when its power is more than six, so it's false. Okay, here we can solve any polynomial to the power n, of course, based on the method of Mourad Sultan Ezouidi. Okay, so learners, I'm going to start. Okay, just I will give you a few seconds. Okay, then we start, learners. It's an occasion for you, learners, to start working with polynomial to the power n. Okay, also I published more than 5 books dealing with solving polynomial to the power n. Okay, okay, playlist. Okay, polynomial to the power 5. Okay, start and see. Okay, so prepare yourself, learners. I'll give you a few minutes. Okay, that's 1 or 2 minutes. Okay, to join first the lecture. Okay, then we start. Okay. Okay, I'll see. Okay. Yes, it comes. So we told that we are going to start, learners. Okay, just I'll give you 1 minute. Okay, to prepare calculator, scientific calculator, and prepare also papers and pens, and you are going to work with your mathematics teacher, Mourad Sultan Ezouidi. Let's say through this lecture we learn how can you solve polynomial to the power six, not polynomial to the power two or three, okay, or four or five, okay. Now you are going to jump, make a big jump, okay, or try to climb trees so that you will be able to solve polynomial to the power n. Okay, now learners, we are going to start. Okay, I'll just start here. Okay, here, learners, you can see that this is polynomial to the power 6. Okay, this polynomial raised to the power 6. I'll just make color for it. Sorry. Okay, I will make a blue color. Okay, or green color, it's better. So let's start learning. This is a polynomial to the power 6 simply because the highest power here is 6. So x raised to the power 6 minus 54 x raised to the power 5 plus learners 43,765 divided by the square of 6 multiplied by x raised to the power 4 minus learners minus 3,154,680 divided by the cube of 6 multiplied by x cubed plus learners we can let's say it will be 127,983,353 divided by 6 raised to the power 4 multiplied by x squared minus learners 2,770,748,856 divided by 6 raised to the power 5 multiplied by the x term x here plus what learns you can see that plus we told 121,841 million then 869,248 divided by 6 raised to the power 6 equals 0. Okay, now learners at the same time that your mathematics teacher is showing for you the method how can you solve this kind of questions. Okay, it's not easy in fact. Okay, but according to Mr. Mourad Sultan or according to the method of Mr. Mourad Sultan Ezouidi, you can learners solve any polynomial raised to the power 6. Okay, so just let's start learners. I will start solving. You can see that this polynomial in fact the highest power in fact learners it's clear that is 6. Okay, so we can say the following. Okay, let's focus on this polynomial learners. This polynomial in fact is a polynomial that has a highest power which is 6. So to find, let's say, out the roots of this polynomial, we should determine learn the values of SR of order Q relative respectively to LR of order Q, where R here learners belongs to the set of numbers 0 or minus 1, 0, 1, 2, 3, 4, and 5. Or between parentheses, we can say that R belongs to the set of numbers, okay, from, okay, it will be from minus 1 to n minus 1, okay? And here, let's say, denotes the highest power. So 6 minus 1 is 5, okay? Now we are going to go step by step so that you can understand the method or the discriminant formula that we generalized it, okay? And we applied here in this kind of examples, okay? I just erase this one. Now, learners, it's clear for you that you are going to do a hard work. It's not easy, in fact, learners. Okay, I'll just focus this. I will try to change its color. No. Okay. I will go here. Okay, Mr. Mourad. Okay, good man. Therefore, learners, I will proceed to continue calculating the value of course, the value of SR of ODQ. Okay. Now we continue. I will just start using the formula of Mourad Sultan Ezouidi. You already, let's say now it's the formula is familiar to you, okay, because we practiced this before. and now we'll practice it with the polynomial to the power 6. Okay, I will give you time to think, learners. Okay, so this is the coefficient of my original polynomial to the power 6. This is L0 for the Q is 54. This is L1 of ODQ is this ratio or this fraction, okay, that can be written as numerator and denominator. The numerator is 43,767 and the denominator is 6 squared. And so on. This is the value of L2, this is the value of L3, and this one also the value of L4, okay. Now, learners, I will start working. Of course, every one of you has to prepare or to put his or her calculator on her or his desk, and we are going to start working. So this is the discriminant, what is called the discriminant formula of Mourad Sultan Ezouidi. Okay, we will apply this formula. Whatsoever your polynomial, you should apply this formula. This formula is the formula of Mourad Sultan Ezouidi. Okay, and this work had been done and written after, let's say, 14 years of work, okay, in polynomial. That's why here we reach the method, the correct method, that you will give you exact value or exact roots without error estimation or without uh, approximation method. So let's start learns now. This is if you want to find the value of s minus 1 of order r learns, you should set k equal 0 in this formula. Okay, this is by convention. The value of s minus 1 of order r is equal always to 1. Okay, I will continue. So it's clear for you that the value of s minus 1 of order r is 1. Simply because we are going to calculate the sum that started at 0 and ends with 0. Okay, combination n minus r. Okay, choose r, n raised to the power r between parentheses minus L0 for the q raised to the power negative r, okay, times Lr minus 1 of order q equal s minus 1 of order r, which is 1. Okay, now learners, we fixed the value of s minus 1 in general for any polynomial that you are going to solve. You should first of all try to find a new polynomial, okay, related, of course, to the original polynomial that you are going to use, that we are going to solve. Okay, so now in order to find the value of a 0 learners, you should set k equal 0 in the discriminant formula of Mourad Sultan Ezouidi. Okay, the discriminant formula is that, learners. Okay, this is the discriminant formula of Mourad. Okay, you should, let's say, learners, find the value of S0 for the Q, and you will be, you will, let's say, you will be able to generalize the following fact that S0 for the R always is 0, simply because the sum of x roots of this new polynomial is 0. Okay, now learners, you can, let's say, substitute. Okay, this is just substitution. You will replace r with 0. Okay, till you reach the 1. Means that the sum of r equals 0 up to 1, combination n minus r, choose 1 minus r, and raised to the power r, between parentheses negative 0 for dq, raised to the 1 minus r, times lr minus 1 of dq. This one learns if r equals 0, we will get combination and choose 1. Then r is 0, it will be n raised to the power 0. Times, between parentheses learners, r we told is 0, it will be negative at 0 for the q. 1 minus 0 is 1. Times l 0 minus 1 gives you minus 1 of order q. This one when r equal 0. Now let's replace r with 1, okay? Because r belongs from 0 to 1, okay? R belongs to the set of numbers 0 to 1, okay? Now when let's say r equal 1, it will be combination n minus 1, okay? Combination n minus 1. Choose what learns, choose 1 minus 1, which equals to 0. So combination n minus 1 shows 0. In fact, learns this one is 1, okay? Then n raised to the power r, the r is 1, it will be n raised to the power 1 multiplied by minus L0 of ODQ raised to the power 0. So L0 of ODQ, in fact, is different to 0, which is equal to 54. Okay? Any positive number or negative number that is different to 0, when you raise e to the power 0, you will get 1 always, okay? So it will be minus L0 for the Q raised to the power 0, which is in fact 1, times L1 minus 1 gives you L0 for the Q. Therefore, learners, you can note that, or you can see that L0 for the Q here and here, it's called common factor. I should put this common factor or write this common factor outside the brackets, means I will write it. It will be n minus n, simply because, learners, this is n. I wrote it here. Then minus combination n choose 1 is n times the common factor L0 of all the Q. Therefore, n minus n is 0 times a number that is different to 0 equal to 0. Therefore, for any polynomial to the power n, S0 is always 0, and S minus 1 is always 1. Now, learners, at least we figured out the value of S minus 1 of order R and S0 of order R. Now we should find S1 and S2 and S3 and S4 and S5, okay, to summarize or to rewrite or to write the new polynomial that we are going to find its x roots. And using the, after that, when finding the x roots of the new polynomial, you will just add the L0 for the Q, and you should divide all by n. N is equal to 6, means you are going to divide them by 6 to get the roots of the original polynomial. Okay. Therefore, we continue, learners. Okay. It's an occasion for you, okay, to learn from your mathematics teacher, Mourad Sultan Ezouidi, okay, and to get to know about, okay, to get to know about uh, how can you understand the relationship between the roots of polynomial to the power n, and that is also related to the coefficient of the x term that is written in polynomial to the power n, and also to know that there is a strong relationship between L n minus 1 of ODQ to S n minus 1 of ODQ. This relationship, in fact, it's denoted or it's demonstrated on the formula of Mourad Sultan Ezouidi. Okay, now I will continue, learners. I will just, this is we told I will put it as, I will color with yellow. Okay, now, learners, you can see that here the value of S0 of order R. Okay, we should calculate this, learners. I will just make calculator, okay, to bring my own calculator. And if you want, maybe if I find time, I will show you that this polynomial to the power 6, the GeoGebra can't solve it, okay? Can't solve this kind of question, okay? Because GeoGebra using the method of Newton method, okay, that can be written as xn plus 1 equal xn plus f of xn over f dash of xn, okay? And This one can't work with. Okay, now learners, I will just start. I will use negative 6. Combination 6 choose 1 is negative 6 times learners 54. Okay, 54 plus learners plus 6 times 54 plus 6 times 54. Okay, just okay. This one learners has to be equal to 0. So in general, for the value of a 0 of order r has to be equal to 0. Okay, when r equal 1, when r equal 2, so we are going to talk. We are going to talk about the powers, or the sum of powers of the x roots of this new polynomial that is related to the original polynomial that we try to solve it. Okay, so therefore I will close this one, learners. Okay, we calculated the value of s0 for the r, which is equal to 0. I will give it blue color if it is possible. Okay, now learners, I'm going to find s1 of order r. Okay, to find the value of s1 of order r, learners, we have to set k equal to in the discriminant formula of Mourad Sultan Ezouidi. Therefore, I will just start substituting k with 2, and I will try to find the value of this ik. Here, learners, we can proceed, we can continue developing this formula. Okay, after replacing k with 2 in the formula, we'll get sk minus 1. In fact, learners, is s2 minus 1 is 1 of order r, of course, equal the sum from 0 to 2 combination n minus r. Choose 2 minus r n raised to the power r, between parentheses negative 0 for the q uh, raised to the power 2 minus r times lr of minus 1 of O the q. After developing this discriminant formula of Mourad Sultan Ezouidi, we will obtain the following. If you want, I will explain this step by step. Okay, when r equals 0 in the formula, it will be combination and choose 2. Then n raised to the power 0, no need to write it. Okay, I'll just write negative 0 for the q raised to the power 2 minus 0 is 2. And a negative number raised to the power an even number has to be positive. That's why here it's written combination to choose n L0 for the q raised to the power 2 minus, when r equal 1, learns, it will be n raised to the power 1. So that is n, means n. Then combination n minus 1, choose 2 minus 1, means combination n minus 1, choose 1, because 2 minus 1 is 1, times L0 of all the q raised to the power 1, and the negative sign comes because this value, negative L0 for the q raised to 2 minus 1 is 1. Okay, negative number raised to the power an odd number, so it's negative, times L0 for the q. You can see that L0 for the q times itself has to be written as L0 for the q squared. So this one, it's common factor. I'll try to simplify the first two terms only, and the rest never change. Means that when r equal 2, it will be n squared. This one, it will be 2 minus 2, 0. N minus 2 choose 0 is 1. N raised to the power 2. And this value is 1 because 2 minus 2 is 0. Minus L0 for the q raised to the power 0 is 1. Then L2 minus 1 gives you L1 of the q. Therefore, learners, you can see that L0 for the q squared, I will write it as a common factor outside the brackets. Therefore, I will write combination and choose 2 minus n combination n minus 1 choose 1. This value, learners, has to be written as that. Minus combination 1 choose 1 times combination and choose 2 times L0 for the q all squared plus n squared times L1 of ODQ. So this value of S1, this S1 learners, this is what you already know. That is the quadratic formula, the opposite of the quadratic formula of the value of quadratic formula. Okay, in the discriminant formula of Mourad Sultan Ezouidi, will show you that the value of S1, okay, the general, let's say, formula for S1 is negative combination and choose 2 times L0 of ODQ squared plus N squared times L1 of ODQ. Okay, very important this. Okay, means now learners, you have your calculator and you should try to find the value of S1 of order A. Okay, I will give you time, maybe 2 or 3 seconds or 4 seconds to try to find the value of S1 of order A. Okay, and therefore, learners, I will proceed, continue. Okay, I will try to use my calculator. Okay, the calculator told you that, okay, S1 of order R learners is equal to, you can see in combination, 1 choose 1 is 1, no need to write it, but you should put into consideration the negative sign. Then combination 6 choose 2 is 6 choose 2. It will be, okay, it will be 6 factorial, okay, divided by 2 factorial, divided by 4 factorial. Okay, 6 times 5, okay, 30 minus 15. Okay, I will just write minus 15 times 54 squared. Okay, plus learners plus 6 square multiply plus 6 square multiply learners by this divided by 6 square. No need to write it. I will just write this one because this is the value. This value 6 squared divided by 6 squared is 1. Okay, if you want to write, no problem, I will try to write for you. Plus, we told yes, plus Mr. Mourad, 6 squared is 36 times learners between parentheses. I will try to open a parenthesis times 43,765 divided by 6 squared is 36. I will try to find the value of this. Okay. Okay, I will repeat again. Okay, first of all, I will calculate it. We told 1, 5. Okay, just a moment. We told 1. Okay, 1. Okay, 1, 4. And then 6, 4, 1. And then we have 1. Okay, I'll put T, it's better. But then 1, 5, 10, 10, 5, 1. Okay. And then we have learners 1, 6, 15, okay, 20, 15, 6, 1. Okay. I'll try to, okay, go up. Okay, where is my calculator? This is the calculator. Therefore, we told learners, I will repeat again. So, I will erase all of this, no need for this one. Okay, we told combination 6 choose 2, which is 15. Okay, negative 15. Negative 15. Negative 15 times 54 squared. 54 raised to the power 2. Okay. Plus learners 43,765. This one has to be equal to 25. Okay. This one learners is equal to 25. just okay. Hmm. So this one learns, we told that is equal to 25. Mhm. I will continue now. Now we let's say we found the value of S1 of order R, which is 25. Now I'm going to put K or set K equal 3 to find what learns to find S2. Okay. Therefore, let's see the discriminant formula that has let's see the value of S2 has been derived from the discriminant formula of Mourad Sultan Ezouidi. I will try to evaluate its value, AK, means that learners S2 is equal to the sum from 0 to 3, combination n minus r, choose 3 minus r, n raised to the power r times minus L0 of ODQ raised to 3 minus r times LR minus 1 of ODQ. After developing this or substituting r with 0, 1, 2, and 3, we'll get the following expression. Okay, means negative combination and choose 3, L0 of ODQ raised to the power 3 plus when r equal 1 plus n raised to the power 1, which is equal to n times combination n minus 1, choose 2, times L0 of ODQ raised to the power 2 times L0 of ODQ raised to the power 1 minus combination n minus 2, choose 1, n squared, L0 for ODQ, choose 1, not choose 1, raised to the power 1, times L1 of ODQ. When r equal 3 learners, this one is equal to 1, simply because 3 minus 3 is 0. Combination n minus 3 choose 0 is 1. N raised to the power 3, and this one has to be equal to 1, simply because negative L0 for the q raised to the power 3 minus 3 is the exponent now is 0, and this is different, the value that is different to 0, so has to be equal to 1. Times L3 minus 1 gives you L2. Now, learners, you can see that L0 for the q raised to the power 3 and this are equal, okay? So I will try to simplify only the first two terms and I should keep the rest as they are, no change. Okay. I will proceed, continue learners. Okay. I'll just make like that. Okay. I'll choose the last one. Okay. This is with, okay. Now learners, you can see that we told that L0 of all the q raised to the power 3 is a common factor. Times what? Times negative combination n choose 3 plus n combination n minus 1 choose 2. This is equal learners to 2, or I would just change by combination to choose 1, or just 2. 2 times combination n choose 3 times L0 for the q raised to the power 3 minus combination n minus 2 choose 1 n squared, or the square of n, times L0 for the q raised to the power 1 times L1 of the cube plus n cubed multiplied by L2 of the cube. Okay, I will use the last formula because we developed this and we simplify this as or we wrote this in its lowest term. Okay. Now, learners, I will use the expression of the discriminant formula when uh, when k equals 3, because we told that we should, let's say, set k equal 3 to evaluate the value of S2 of order R. Okay. Now I will continue, learners, proceeding, finding the exact value of S2. Okay, I will use the coefficient of my original polynomial to the power, of course, okay, to the power 6, because I started working, I started working with the polynomial to the power 6, okay, and these are its coefficient, okay. Now I will try to find the value of S2, okay, We'll go step by step, learners. Okay, I will try to find the value of S2. Okay, so learners, we told that the last, okay, we told that that is equal to 2 times combination and choose 3. Or you can also write combination to choose 1 times combination and choose 3 times a 0 for the q raised to the power 3. This is, it's called the general value of the discriminant formula. The general or uh, the value of S2 that has been derived from the discriminant formula of Mourad Sultan Ezouidi. Now I'll just apply this, learners. I will use my calculator, of course. Okay, try at the same time that your mathematical teacher using his own calculator, and you learners, you should also use your calculator. Okay, I will continue. So I will just calculate the value. Means I will replace L0 for the Q with 54 because this is 54. Then I should replace also L1 with 43,765 divided by the square of 6. Then I should substitute L2 learners with 3,154,680 divided by the cube of 6. And I will calculate it. Okay, we go step by step, learners. Okay, I'll put this on the right hand side so you can at least see the calculation in front of you. I will now start working. Combination 2 choose 1 is 2 times combination 6 choose 3 is 20, means 2 times 20 is 40. So I'll just write 40 times 54 raised to the power 3 times 54 or the cube of 54. Okay, raised to the power 3. Then we have negative 4 choose 1 is 4. Okay, why 4, learners? Because minus combination and minus 2 and 6. 6 minus 2 will give you 4. Okay, I'll just write minus 4 times combination. Yes, 4 times 6 square. No need to write it because there is 6 square on the denominator. So this 6 square divided by 6 square is what? I'll just use 54 times what, Mr. Murad? Times 54 times 43,000 times 43,765. Then plus what, learns? Plus the cube of 6 multiplied by 3,154,680 divided by the cube of 6. 6 cubed divided by 6 cubed is 1. I will cancel. They will be cancelled out. Means I will just write the value of the coefficient of L2 multiplied by the cube of 6. Means 3 million multiply, Mr. Murad. We told, okay, minus 4 multiplied by 54 multiplied by, okay, 43,767, correct, plus 3 million, plus, Mr. Murad, plus 3,154,680. So this one, learners, has to be equal to 0. Okay, therefore the value of S2 of order R is equal to 0, and using a calculator at the same time that your mathematics teacher is working and explaining for you how can you use his own discriminant formula, okay, to solve for x any polynomial to the power 6. That's good. That's meaning that you are very smart, my learners. Other teachers or professors or student or anybody who is now watching or joining the lecture, it's an occasion for you to learn from you, and you will understand what is a polynomial, and you will raise a question, what is a polynomial? Okay, yes, in fact, it's a good subject. Okay, a good specialization, when you specialize in a topic, or and you let's say and you summarize the whole context, means that you are very smart. Okay, and you should share your knowledge. Okay, to improve yourself first, to improve yourself, or to educate yourself, that if you know something you can share it. Okay, so we continue learns. Now we found the value of what learns. We find now the value of s2 of order r, which is equal to 0. Okay, we continue. We will try to find the value of S3. Means that learners, S3, you should use the discriminant formula of Mourad Sultan Ezouidi. Okay, I will try to use this if it is possible. Okay, okay, Mr. Mourad, go up. Okay, go here. What is it? What is it, Mr. Mourad? Go here, Mr. Mourad. Again. Okay, I will come here immediately. Okay, this is the S3 of order R. I will take this. I will take only this copy, and I will close this one. Okay. Now, learners, I will just write something here. Use the question. Use the discriminant formula of Mr. Mourad Sultan Ezouidi. Sultan Ezouidi. So the formula tells you, sorry, Control V, Mr. Mourad, tells you that this is the formula. I will just write it again for you. Okay. How can I change this, Mr. Mourad? Okay, no problem. I will take it. Okay, I will take it from the beginning. Okay, give me a few minutes, learners. Okay, I'm coming back. I will just take this. Okay, copy. Comes down, go back. Control V. This is, learners, the formula, discriminant formula of your brother Mourad Sultan Ezouidi. Okay, this is, of course, is K. Okay, this is K minus 1. K minus 1. This is, of course, is K minus R. Okay, so this one formula, class, I will take it. Control X, no need. Okay, I will close my box. Now, learners, I will just proceed. Okay, I will make it where exactly. Okay, no problem. So this one, learners, it's called what? It's called the discriminant formula of Mourad Sultan Ezouidi. This discriminant formula will help you to find the value of the coefficient of the new polynomial that has a relationship to the original polynomial. Okay, it's called a general formula. Okay, so let's focus on the following shapes. Mr. Mourad, this one. Okay, no problem. Okay, so with all this is the discriminant formula of Mourad Sultan Ezouidi. We'll apply this. Okay, means that, learners, we told this is the formula, isn't it? I told that put k equal 4 to find S3. If you want to replace k with 4, it will be S4 minus 1 of order R. means S3 of order R equal the sum from 0 to K means K is 4, sum 0 to 4. Combination N minus R, combination N minus R, choose K minus 4. K is 4. So, sorry, choose K minus R. K is 4. It will be 4 minus R. N raised to the power R. Okay. Minus L0 for the Q raised to the power K minus R. Well, K is 4. Okay. Times LR minus 1 for the Q. This we replace K with 4 to find the value of S3 of order R. Okay? Then the rest will be easy for you because this is an advanced course, okay? An advanced lecture, okay? And also this one, it's an occasion for professors, to learn, to understand the big relationship between the discriminant formula of Mourad Sultan Ezouidi that had been, let's say, generalized for any polynomial to the power n. Okay? Okay? Therefore, we continue learning. We told that S3 is equal to that. After putting R equals 0, we will get combination and choose 4. L0 for the Q raised to the power 4 minus n minus 1, choose a 3 times L0 for the Q raised to the power 3 times L0 for the Q plus combination n minus 2 because R is 2. Choose 4 minus 2 is 2 means combination n minus 2, choose 2. N raised to the power 2 times L0 for the Q raised to the power 2 times L1 for the Q. When R learns equal 3, we'll get n minus 3. That's why it's written n minus 3. Choose what? Choose 4 minus 3 will give you 1. And the negative sign comes simply because you will get negative L0 for the Q raised to the power 4 minus 3. 4 minus 3 is 1. Negative L0 for the Q raised to the power 1 is negative L0 for the Q. That's why I wrote the negative. I show you the negative sign here. Then, okay, plus when R equal 4 learns, you can see that combination n minus 4, choose 4 minus 4. This is 0. So combination n minus 4 choose 0 is 1. That's why we ignored it here. Times L3 of ODQ. Okay. Now, learners, you can just focus on the first two terms of the discriminant formula of Mourad Sultan Ezouidi. When k equals 4, you will see that L0 for the Q raised to the power 3 times L0 for the Q is called common factor. I will put this common factor here, learners. The rest will be written as they are, not changed, okay? Mean the developed expression and the values of Cn minus 2 choose 2 when squared, L0 squared, L1 minus these two terms will be written as they are. Okay? I will just simplify the first two terms. So I put L0 for the Q raised to the power 4 times combination n choose 4 minus n combination n minus 1 choose 3. The difference between these two terms has to be equal to negative combination 3 choose 1. Okay? Times combination n choose 4. L0 for the Q raised to the power 4 plus combination n minus 2 choose 2 and squared. L0 for the Q squared. Okay? Times L1. Then learns, okay, minus what? Minus combination n choose, okay, make enter. Okay, n choose what, learners? N minus 3 choose 1 times what? Times n cubed, okay, times n cubed, Mr. Mourad, okay, times L0 for the Q times L2 plus n raised to the power 4 times L3 for the Q. Okay, now learners, we want to calculate the value of S3 if it is possible. Okay, let's calculate together so that you will be familiar with the discriminant formula of Mourad Sultan Ezouidi, and it's an occasion for you to understand the main function, okay, that will relate this new polynomial that we are going to find in the origin polynomial. After that, you can summarize, or you can distinguish, or you can know about the roots of your original polynomial to the power 6. Okay. So this method will lead you exactly to find the exact values or the exact roots of your original polynomial. Okay, meaning that there is no error estimation. Okay, there is no roots that will be based on approximation. Means we will never use approximation. Okay, we just give the exact values or the exact roots of any polynomial. Okay. Now learners, we reach to complete. Okay, means we'll make a big. We'll okay. I forgot the word. Big class. Yes. Okay, because we reach to complete. Okay, our work. Okay. Now learners, it's easy now to find the value of S4. Okay, we should substitute k with 5, of course, in the discriminant formula of Mr. Mourad Sultan Ezouidi. I will take to learners if it is possible. Okay. Okay, Control C. Okay, come there, Mr. Mourad. Go down. Okay. Now, learners, we told that if you want to find the value of S4 of order R, you should replace K equal 5 in the discriminant formula of Mourad Sultan Ezouidi. Okay, let's see the discriminant formula of Mourad Sultan Ezouidi. You should be familiar with this, learners. Okay, I'll just put this here because it's very important. Okay, any polynomial that you are going to solve, learners, you have to use this method. Okay, and between parentheses, I already published 3 books. Okay, each book, let's say, consists of 164 pages. Okay, and through this book, you will learn new methods. Okay, and you will get the exact value or the exact roots of the polynomial that we worked that had been written in these books. Of course, raised to the power 4, 5, 6, and so on. I'm going to, in fact, I'm planning for preparing other books, okay? Solving polynomial to the power 7, to the power 8, to the power n, 9, to the power 10, okay? And I, in fact, solved polynomial to the power 18 and 30, and I published this on the edition European Universities, okay? And but yes, and we are um, looking for letting you diving into this deep research, okay, and deep work, sorry, okay, and we hope so that you will get the idea how can you also solve them to the power 5, 6, 7, and 8, and 10, and 20, 30, 31, whatsoever the power of this polynomial. Okay, you just think of the discriminant formula of Mourad Sultan Ezouidi, and you will work and will find all the roots, okay, of the polynomial that you are planning for solving for x, that you are planning for solving it. Okay, now learners, I will just continue. Okay, at the same time, learners try to also uh, find at the same time the value of S4. Okay, I will just now use this one. S4, I will use green, it's better. Okay, of course, I can change the color. Okay, and also this work is addressed to everyone. Okay, addressed also to the universities in the whole world. Okay, to understand um, this formula, okay? And many formula, in fact, I discovered, okay? And now it's time to let you know about them, okay? So therefore, learners, we told that to find the value of S4, you will just replace K with 5, okay? Because from the beginning, we told that for K equal 5, we obtain, means that you will use the discriminant, okay? The discriminant formula of Mourad Sultan Ezouidi, and you will get Sk minus 1 of order R equal the sum from 0 to K combination n minus r, choose k minus r n raised to the power r, between parentheses negative L0 of order q raised to the power k minus r times l r minus 1 of order q. Okay, so this formula will help you to find the value of S4 because uh, we found already the values of S3, S2, S1, okay, S0, and S minus 1. It remains now just to find S4 and S5. When you reach S5, means n minus 1, Sn minus 1. And n is 6. So 6 minus 1 is 5. The last coefficient of your new prime to the power 6 is S5. Okay? Now, learners, just substitution. You will replace k here with 4, with 5, sorry. 5 minus 1 will give you 4. The sum from 0 to k is 5. K 0 to 5. Combination n minus r. Choose 5 minus r because k, from the beginning we told that you should set it as 5. Okay. So combination n minus r, choose 5 minus r, n raised to the power r, between parentheses, negative 0 for the q, raise it to the power 5 minus r, times l r minus 1 for the q. Now let's develop this, or let's express this differently. Means that you will put r equals 0. You will get this value. Minus combination n, choose 5, add 0 for the q, raised to the power 5. When r equal 1, it will be n combination n minus 1, choose 4, add 0 for the q raised to the power 4, times add 0 for the q. This and that, call it common factor. I will try to write them here. It will be negative combination n, choose 5, plus n combination n minus 1, choose 4, and 0 for the q raised to the power 5 means I just simplified the first two terms. The rest, when r equal 2, when r equal 3, when r equal 4, and when r equal 5, no change for this four terms. 1, 2, 3, 4. Okay. Means I will write this as they are, no change from here, because negative combination n minus 3 n squared L0 for q raised to the power 3 times L1 for the q is this. And the next term, okay, it will be combination n minus 3, combination n minus 3, choose 2, okay, n cubed, L0 for the q raised to the power 2, okay, L2 for the q, L2 for the q, minus combination n minus 4, choose 1, okay, times n raised to the power 4, times L0 for the q, times L3, plus the last term n raised to the power 5 times L4 for the q. Therefore, just I told you that I should simplify the first two terms. The first two terms, when putting L0 for the q raised to the power 5 as a common factor, you will get combination 4, choose 1, combination times, of course, combination n, choose 5, L0 for the q raised to the power 5. Why this is positive? Because the index here is positive, is even number. If it is odd number, you should write here negative sign, okay? So I told that I simplified the first two terms and I wrote them in its lowest term, okay, and the rest had been written as they are, not changed. Now, learners, I will use my calculator. At the same time, you are using your calculator and to find the value of this, okay. Here is my calculator, Mr. Mourad Sultan Ezouidi. I'll put here if it is possible. Okay, so let's start, learners. This is the 0. I will start. Okay, we start, learners with all that. Okay, I will try to find the value of S4 of order R is written as combination 4 choose 1 means what learner means 4 times combination 6 choose 5 means what learner means times 6. Okay, times 6 times what learners times 54 raised to the power 5 times, oh, where is it? My calculator. Why you were, okay, times we told, okay, 54 raised to the power 5, I think. Yes, raised to the power 5. Minus combination 4 choose 3 is 4. Minus combination 4 choose 3 is 4. Minus 4. Times learns what? Times 50, the cube of 54. Okay, times 43,765 divided by 6 square, and here multiplied by 6 square. This and that will be cancelled. I will just write this value times this times the numerator value only. Means, okay, minus 4 times 54 cubed, okay, times learners, okay, 43,765. Okay, I finished the second term. Now, combination 3 choose 2 is 3. There is a plus. I will make plus. Okay, plus 3 means times learns, you see, 6 cubed divided by 6 cubed will be cancelled out. I will just write the square of 54 times Mr. Mourad plus 3, okay, times 54 squared. Good man. Okay. Times what learners? Times 3,154,680. Okay. I will just write here. Okay. 3 times 54 squared. Okay. 3 times 54 squared, correct. Times 3,154,680. I will check again. 3,154,680. Good man. Now, minus what learners? There is negative sign, simply because here is a negative sign. Minus combination 2 choose 1 is 2. Minus 2. Times what learners? 2 times 6 raised to the power 4 divided by 6 raised to the power 4. It will be cancelled out. It will be cancelled, okay? Means you can reject these two terms, two values, because the ratio of it is 1. So multiply by only 54. Multiply, Mr. Mourad, by 54 only. Times what learners? Times this one, times S3. L3 means, okay, means 127,983,354. I'll just write, make, multiply Mr. Mourad by 127 million, okay, 983,000, correct, 354, 354, correct. Okay. This one has to be equal, learners, what? Sure. Okay. Okay. I will repeat again. Okay. This one, okay, 100. Okay. Just one moment. We told 127,983,000. Okay. 354. Good. Okay. Okay. S4. Okay, I will repeat this again. I will calculate this again. Okay, I will make bigger if it is possible. comes here, Mr. Mourad, and put your calculator. Okay, this is, okay, make bigger, it's better, no problem. So I will just start again. Okay, I will calculate the beginning. So 4 times 6 is 24. 4 times 6 is 24. Okay, times 54 raised to the power 5 times 54 raised to the power 5. Good man. Minus 4, because okay, 3 choose 4. Yes, 3 choose 4, Mr. Mourad. Minus, okay, yes, minus 4 times 54 raised to the power 3, okay, times 43,765. Then we finish the first two terms, we move to the second one. Okay, plus 3 multiplied by the square of 54, square of course, okay, times Mr. Mourad, 3,154,680. Okay, minus 2 times 54 only, times 127 million 983,354. Okay, plus learners, because here 6 raised to the power 4 divided by 6 raised to the power 4, no need to write them, plus 6 raised to the power 5 times 2,770 million 748,856 divided by 6 raised to the power 5. Do you see this? 6, 5. 6, 5 will be 1. So I'll just write, okay, plus, because this is a plus, okay, we thought minus 2 times this, okay, plus learners, plus 2,000 plus 2,770, okay, 2,770, 700, I will just write this one, 2,770, then 748,000, correct, 856. This one, learners, has to be equal to what? 0. Yes, okay. This one has to be equal to 0. Okay. I'll just make this bigger for you. Okay. This one. Okay. I will make copy if it is possible. Okay, copy. Then I will. Oh my God! Why, Mr. Mourad? Why, Mr. Calculator? Don't calculate. Don't cross it. Okay. So, okay, I will make bigger. Therefore, to that, this is what I paste. This one. Okay. I will try to make it small if it is possible. Or I'll make enter here. Okay. Good man. I'll come here, learners. Okay. Look, we told that 24 times 54 raised to the power 5, correct, minus 4 times 54 raised to the power 3 times 43,765, correct, plus 3 times 54 squared, the square of 54, times 3,154,680, minus 2, because combination 2 choose 1, times 54 raised to the power 1, times 127,983,354, plus what? Plus learns 2,770 million, then 748, then 748,856. 800. This one has to be equal to what, learners? Equal to 0. Okay, this one is equal to 0. Okay, we calculate, you can use your calculator. Now we cancel the, sorry, I will close this one. I will now use this. Okay. Control C. Now we now found the value of S4, that is learners equal to 0. Okay. This is the value of S4. Now I will try to find the value of S5, and we reach to make conclusion, to conclude the roots of the original polynomial. Okay, I'll make color, Mr. Mourad. No, Mr. Mourad, not like that. Okay. Also, I have another friend, mathematical teacher, whose name was Habib Shibanilani, who will, inshallah, as soon as possible, he will start solving or explaining my method, okay? And he will explain in French. Me, I can explain in French, but it's a lot of work for me. I prefer to explain this in English, okay, not in French. But my friend, he will start explaining the whole book, okay, in French. Okay, for those who understand only French, it's an occasion for them to understand. Okay. Now, learners, I will just continue. Last part. Okay. No, not. Maybe like that. Okay. I'll make it blue. It's better. Okay. Now, learners, we continue. Mean that we should find the value of S5. And when you reach S5, means you reach the last coefficient of your original polynomial, of your new polynomial that has been derived from the original polynomial. Okay, I will continue, learners. Okay, so this one is the formula for k equals 6. Okay, we will write the following. This is first the discriminant formula of Mourad Sultan Ezouidi. Okay, I will just substitute k with 6. Okay, means S6 minus 1 will give you S5. K is 6. That's why he is written 6. Combination n minus r, choose k minus r. K is 6. That's why here we wrote it as combinations n minus r, choose 6 minus r. N raised to the power r between parentheses, negative 0 for the q raised to the power k minus r. K is 6. That's why here it had been written as an exponent 6 minus r times lr minus 1 for the q. When developing this discriminant formula for k equal 5, for k equal 6, means you generalized a formula that you generalized a formula that will work with any polynomial to the power n. Means if you want to solve polynomial to the power n, you should find s minus 1, s1, s0, s2, s3, s4, s5, and so on, till you get sn minus 1. And s5 for any polynomial has to be written as that, the last part, you see. S5 r equal negative combination 5 choose 1, L0 for the q raised to the power 6, plus n squared L0 for the q raised to the power 4, times L1 for the q minus n cubed L0 for the q cubed times L2, plus n raised to the power 4 L0 for the q squared, L3 for the q minus n raised to the power 5 times L0 for the q raised to the power 1 times 4 of or the q plus n raised to the power 6 times L5 for the q. This one, learners, is the last for concluding or for writing your new polynomial that we will work with. Okay, means just here substitute, learners. L r equals 0, you will get combination n choose 6, L 0 for the q raised to the power 6. When r equal 1, you will get minus n combination n minus 1 choose 5, L 0 for the q raised to the power 5 times L 0 for the q. When r equal 2, you will get n minus 2, that's why here it's an n minus 2, then 6 minus 2, that's why here it's 4, n raised to the power 2, okay, because r is 2, n raised to the power 2 times L0 for the q raised to the power 4, okay. Why plus here? Because the negative sign raised to the power an even number is positive, okay, times L1 for the q. When r equals 3, learns, we will get negative combination n minus 3 choose 3, because 6 minus 3 is 3, n raised to the power 3, L0 for the q raised to the power 3 times L2 for the q. When n equal 4, learns, we will get n combination n minus 4 choose 2, n raised to the power 4 times L0 for the q raised to the power 2 times L3 of 4 the q, minus when n equal r equal 5, you will get here, though this minus comes, learns, because minus L0 for the q raised to the power 6 minus 5. 6 minus 5 is 1. Minus L0 for the q raised to the power 1. Okay, that's why here we wrote the negative sign in front of the combination n minus 5 choose 1 times n raised to the power 5, okay, L0 for the q raised to the power 1 times L4, okay, and there is here plus the last term, is it? Plus here, learners, you can see this one, plus what? Plus n raised to the power 6 times L0 for the 5. I will just make here enter, so you can see it again. I will make this, okay, no need for this, just I will appear the, what is it? Again, Mr. Mourad, go back. Okay, make it bigger so you can see it. This one is that, okay. Now I thought it's clear. Okay, plus the last term, learns, is n raised to the power 6 times L5 for the q. Why? Simply because combination n minus r choose 6 minus 6 is 0. Combination n minus r choose 0 is 1. Then n raised to the power 6 because Lr is 6. Okay. Then this one has to be equal to 1 because negative L0 for the q value or a number that is different to 0 raised to the power 0 is 1. That's why here no need to write it as 1 because it's clear for you. Then 6 minus 1 gives 5. Okay. Now just focus on the first two terms. Only 6 n choose 6 as 0 for the q to the power 6 minus n combination n minus 1 choose 5 as 0 for the q raised to the power 5 times as 0 for the q. This has as a common factor L0 for the q raised to the power 6. I will write here 0 for the q raised to the power 6 times between parentheses combination n choose 6 minus n combination n minus 1 choose 5. Okay, this and the rest has to be written as they are. You cannot simplify. Okay, just when you want to find the value of S5, just replacing L0, L1, L2, L3, L4, L5 with their own values. Okay. Now, learners, we can note that as this implies that this arrow means this will give you, we will obtain, will imply that S5 of order R equal, the difference between these two terms, okay, is negative combination 5 choose 1. Okay, times combination 6 choose 6 is 1. You can simplify this if you want, but this is the regular formula. Okay, L0 for the q raised to the power 6 plus combination n minus 2 choose 4 n squared L0 for the q raised to the power 4 times L1 of the q minus combination n minus 3 choose 3 n cubed L0 for the q cubed L2 for the q plus combination n minus 4 choose 2 yes n raised to the power 4 times learns what times L0 of the Q squared times L3 of the Q minus combination n minus 5 choose 1 and cube and raised to the power 5 times L0 of the Q raised to the power 1 times L4 plus n raised to the power 6 times L5 for the Q. Now let's see the last formula. Means that any polynomial has to pass through the sk minus 1. Okay? Means if you have polynomial to the power 7, you should find S6. You should find S1, S2, S3, S4, S5, and S6, and so on. Okay? And you will use the discriminant formula of Mourad Sultan Ezouidi. And we hope so that my colleague, Habib Shibani Lani, will start, inshallah, as soon as possible. I will meet him and I will fix a rendezvous with him so he can explain this formula, the discriminant formula, in YouTube channel to help you understand, especially those who can't understand English. Okay, it's an occasion for them to understand these techniques, these strategies in French. Okay, me, as I told, I can speak French. I have no problem. Okay, I'm educated in French. I already studied mathematics, science, physics, chemistry in French. Okay, till the university. Okay, when I got my own bachelor degree in university. But as you know, that I worked in international school. Okay, and the international school, let's say, spoke only English. That's why I I used to speak in English. Okay, this is doesn't mean that I can't speak French. No, of course I'm good at French as English as it is. Okay, and Spanish also. Okay, and Italian. Okay, and we hope so. The most important thing is that you will get the new theorem of Mourad Sultan Ezouidi. Not only this formula, learners. There are so many formula. Okay, there are in fact so many formula of Mourad Sultan Ezouidi, and we hope so that step by step, when university will be ready to get, let's say, to know about these methods. Okay, I will explore. I will tell you uh, more and more about polynomial. Okay, but now we go step by step to let you understand first. Okay, and to let you solve polynomial to the power n with no error estimation, meaning that you will get the exact values, the exact roots. Okay, and remember me. Let me remember, if it is possible, of course, to give you this example on GeoGebra, and you'll see that it's impossible to solve it. Okay. But by the way, we are here to let you know that we can do this, and you can do this if you learn from Mourad Sultan Ezouidi, and this channel is going to be free for you. Okay, it's going to be free. Okay, I'm not looking for money. I'm looking for smart mind like you, smart minds, Mr. Mourad, plural, many minds. Okay, I'm looking for smart minds like you, and it's an occasion to get the point. Okay, I wish that you got the point between parentheses, and I will close the parentheses. We continue. Therefore, learners, we thought that it's possible to believe in yourself, and to believe that we can really solve problem to the power. And okay, please, before continuing, I want to tell you something that you cannot also only solving problem to the power n. Okay, when you use the discriminant formula of Mourad Sultan Ezouidi, you will automatically solve equation to the power n. Means there is no power, but it's written as y subscript n minus L0 of ODQ, y subscript n minus 1, and so on. Okay, means really big work. Okay, an immense work, it's a French word. Okay, means that you will get new things to work with and to know about. about cable. I'm sorry. Now, learners, we continue. We told that we just focus on the last formula that had been derived from the discriminant formula of Mourad Sultan Ezouidi. When k equals 6, you will get this one as 5 for the r equal negative 5. Choose 1 at 0 for the q raised to the power 6 plus n squared at 0 for the q raised to the power 4 times L1 for the q minus any cubed learners, any cubed, sorry, the cube of n, yes, Mr. Murad, times the cube of 0 for the q times L2 plus n cubed n raised to the power 4 times L0 for the q squared times L3 for the q minus n raised to the power 5 times L0 for the q raised to the power 1 times learners L4 for the q plus n raised to the power 6 L5 for the q. Okay, we will replace the coefficient of my original polynomial in this expression and we try to find the value. At least prepare yourself, learners, because you are going to calculate with Mr. Mourad Sultan the value as 5. Then we will try to conclude. Okay. Okay. And we continue, learners. Okay. Okay. This is I'm making. Of course, I will give you method. This is the most important method I should know about it. Okay, it's very important for you learners. Now I will just focus on this one. I will see why. Okay, I will make it bigger for you, like that. Then I should bring my calculator. This is the value. This is S5, learners, the formula. We just replace. Okay, if you want, I will make it clear for you. I will put like that. Okay. And then I will make it like that. Okay, I will close this one. So, I'm go back. Okay, yes. Now I will use my calculator. It's clear for you that you can see my screen there, isn't it? I will put this here in front of you, or down, or I will make like that. If it is possible. No, up. So we can see the coefficient of. I want you to see the yellow coefficient of the original polynomial that we'll use in this discriminant formula that has been derived from this value of S5 that has been derived from the discriminant formula of me. Okay, means according to me, we can find the value of S5 using my own discriminant formula of any polynomial to the power n that I will work with. Okay, I will start. So at least you will calculate with me. You can see that negative 5 times 54 raised to the power 6. I will write negative 5 times what, learns? Times 54 raised to the power 6. Okay. Then plus 6 squared divided by 6 squared. You can ignore this step because it's 1. No need to write it. I'll just write plus 54 raised to the power 4. Okay. 54. I'll just make plus. Yes, Mr. Murad. Plus 54 raised to the power what? Yes, to the power 4. Okay. Times learners 43,765. We finished the first two terms. This is minus plus. Now minus 6 cubed divided by 6 cubed is 1. Just write 54 cubed times 3,154,680. Therefore, I will just write minus now, minus Mr. Murad, 54 cubed, because it's raised to the power 3, okay, times what? Times L2. L2 is 3,154,680, okay, so times, just one moment, negative 54 raised to the power 3, yes, times again, Mr. Murad, times 3,154,680. Correct. Then plus 6 raised to the power 4 divided by 6 raised to the power 4. No need to write it. Just write plus 54 squared. Plus learners 54, the square of 54, the square of 54. Times learners what? Times L3. L3 is 127,983,354, which is this. 127,983, yes. Therefore, I'll just make multiply, Mr. Mourad. Why doesn't that multiply by? We told 100. 127 million 983,354. Okay, we finished this. Okay, plus the square of 54 plus the square of 54 multiplied by 127,983,354. Good man. Minus 6 raised to the power 5 divided by 6 raised to the power 5 is 1. Just write minus 54 multiplied by 2,770,748,856. I'll just write learners like that. Minus now. Minus 54 only. Times 2,770 million. Okay, 2,770 million, 748,856. Okay, therefore, I'll just write 2,770 million, 748. Check again, 748,856. Okay, then plus what? This is a plus. I'll make plus. Plus, learners, you can see that 6 raised to the power 6 divided by 6 raised to the power 6 is 1. Just write this. The last term, which is the last coefficient, it will be learners 121,841 million 869,248. Therefore, I will told that there is a positive sign. I will make positive sign. Okay. We told 12, 18. Okay, 12, 18. 41, 86. 41, 86. 92, 48, I thought. Okay, I will check again. So, 121,841 million. Okay. 121,841 million. Good man. Okay, 841 million. But then after 869,248. So this one has to be equal to okay, I will repeat this calculation again. Okay, we repeat again, learners. Okay, I will make this bigger. You can see it. Okay, this is S5. I will put this here in front of you. I will calculate the first two terms first. Okay, we have -5, again 0, -5 times 54 raised to the power 6. Okay, plus 54 raised to the power 4. Good man. Times 43,765. Correct. Minus 54 raised to the power 3. Okay, times 3,154,154 680. Okay, we finished the first, the second, the third. Now we move to this plus 54 squared, or the square of 54, times, okay, 127 million, 983, 354. Correct. 354. Okay. It remains only the two last. Okay. Minus, this is minus 6. That 6 no need, because 6 raised to the power 5 divided by 6 raised to the power 5 is 1. Minus 54 only. Minus, we told, minus 54 times 2,770 million. Okay, 748,856. Okay, plus learners, plus, okay, plus what? Please again. Plus. Of course, here we'll divide by. Okay. This is 0. Again. Let's check first who is calling me. Okay. I'll check this one. Okay. So this is okay, 76. This is 3,154, 3,156.80. Correct. This is 127, 983. Okay, 354. Correct. بعدين 2,770. Correct. 748. Correct. 856. Okay. بعدين 121, 841, 869, 248. Okay. I'll check the last value, this one. Copy. Go back. Okay. Go back to the original polynomial. 128. 121, 841, 869, 248. Okay. As we move, continue. We continue, learners. Okay. S3 we calculated S3, or check S3 calculated before. S3, the value of S3, yes, 114. Okay, 114. Therefore, now, okay, I will apply the formula now. Okay, negative 554 raised to the power 6 plus n squared 6 squared 54 raised to the power 4 times 43,765. Okay, times, okay, L1 minus 6 cubed n cubed 54 raised to the power 3 means L042 raised to the power 3 times L2 is 3,154,680, correct? Okay, plus Mr. Murad, plus what? Plus n raised to the power 4 means 6 raised to the power 4 times 54 squared, correct? L3 is that 127,983, 127,983, 354, correct? Plus minus n raised to the power 5, 54. Okay, L4 is 2,770, 488, 56, correct? Okay, now I will continue. Okay, I will do this here. I will calculate it. So we have negative 5. Negative, we told 1 choose 5. One choose 5. Yes, because this one will give you negative. Okay, 1 and minus 1 means 6 minus 1 is 5. Okay, so I'll just write now. I'll calculate again. Negative 5 times 54 raised to the power 6. Maybe I wrote raised to the power 5. Maybe by mistake here. I wrote 5. But here it's written raised to the power 6. Plus, because a lot of work, plus 54 raised to the power 4. Correct. Times 43,765. 765. This one. Minus learn is what? Minus 54 raised to the power 3 times what? Times learners 3,154,600. Yeah, of course, 3,154,680. Okay. Minus, of course, minus. Okay. After that, there is a plus. Plus what? Plus 54 squared. Or raised to the power 2, no problem. Okay. Times, therefore, L3 is 127,000 million, sorry, 983,354 minus, okay, 127,983,000. So I'll just write multiply by 127,983,354. Okay, okay. Plus. Now we move to this one. Minus what? Minus learners 2,770. Okay, I'll show you this one exactly where. This one. Okay, this is 2,770. Okay. 748, 856, correct. So I'll just write now. Write 748,000. Okay, 748,856. 856. Okay, this has to be equal to. Okay, yes, you see, it will be okay. 121,841, 1,869, 258. Yes, this one 5, Lorenza. This is 5. Okay, I'll go back. So, okay, equal, Mr. Murad, Mr. Murad. I'll just repeat the calculation. This is 4, this is 8. Okay, I will repeat the calculation. It will be negative 5 times 54 raised to the power what? Raised to the power 6. 6, not 7, 6. Okay, plus 54 raised to the power 4. Okay, negative 5 multiplied by 54 raised to the power 6 plus 54 raised to the power 4 times what? Times 43,765 minus 54 cubed times learners times 3,154,680. Okay. Minus قلنا صح. Now plus the square of 54 multiply by 127,983,354. Again, Mr. Murad. So 54 squared multiplied by 127,983,354. Correct. Then there is minus what? Minus 54 times 2,770,748,856. So just write minus 54 only because 5 divided by 6 raised to the power 5 is 1. So just minus 54 times what? Times 2,770, I thought million, okay, 2,770 million, 748,856. Okay, this one, okay, equal. Oh, should play it. Okay, divided by 6 raised to the power 6. Okay, so just do it again, please. Or I will use my calculator. I will use my calculator. It's better. Okay, calculator. So that scientific calculator. Okay, we have negative 5 times 54 raised to the power 6. Close the parentheses. Okay, plus 54 raised to the power 4. Close the parentheses. Multiply by 43,765. 43,765, yes, minus 54 cubed, multiply by 3,154,680. 680 plus 54 squared, the square of 54, times 127 million. Okay, 983,354. Okay, minus 54 times learners 2,770. Okay, 748. 2,770 million, 748,856. 856. This one equal. Okay. So this one has to be equal to that. Minus. So this one, learners, is equal to, you should make like that. This one is 25 0 0 7 8 20 8 20 120. Okay, again 2,500 million 700 and again 2500 7820 120. Okay, I'll check now the calculator value. I'll check again here. So 250082. Okay, this one. Okay, now this one, we'll just put this here. I'll make copy, or I'll make this one. It's better. Copy. Okay, so the value of this is that okay. I'll just ignore the comma. Okay, let's check this one, learners. I will close this so that I will. Okay, I will make this bigger for you. You can see it at least. Okay, I will use the calculator and we'll check. I'll put this up. Okay, you can see now. I will calculate this. -5. Okay, -5 times 54. 54 raised to the power 6. Okay. Plus 54 raised to the power 4. Plus 54 raised to the power 4. Okay. Times 43,765 minus 54 cubed. Okay. Times what? Times, learners, 3,154,680 plus 54 squared, 54 squared, correct, times, learners, times 127,983,983 354. 354. Okay, minus 54 times what, Mr. Mourad? Times 2,770 million, 748 856 plus what? Plus the last term is 25,007,820,120. I'll just write plus, or I'll make here plus on the calculator. Plus what? Plus 25,007,820,120. This one has to be equal to what, learns? Equal to 0. Okay. Therefore, I will just use this one, copy and paste. Okay. I'll just ignore this one. Control V. No. Go. Okay. I'll put here. Okay. Okay. No. Go back. And this one. Give me this. Alas. Okay. Shit. Okay, Control V. Yes, like that. Go back here. Let's erase this. No need. Okay, go here, Mr. Mourad. The same here. I'll change this one. Okay. Of course, this one. S2, S3. So now, learners, we calculated S0, S minus 1, S0, S1, S2, S3, S4, S5. Okay. And we'll continue grouping, let's say, grouping the values of SR and writing them into a new polynomial to the power 6. Okay, this one. Okay, we continue. Now, learners, we continue. We told that we calculate really the values of S minus 1, S0, S1, S2, S3, S4, S5. Okay, now we are going to write our new polynomial to the power 6. Okay, of course, using the discriminant formula of Mourad Sultan Ezouidi. Okay, we continue. So we told that, in other words, S0 is equal to 0, S2 is equal to 0, S4 is equal to 0, S5 is equal to 0, except S1, which is equal to 25, and S3 equal 114. Now, we'll try to write our new polynomial that has been derived from the discriminant formula of Mourad Sultan Ezouidi. Okay, I will use this green. Okay, let's do this one. So we told that I will see first who called me, who will make a call for me. Then I will come back to you, learners. Okay. Okay. So we continue, learners. We told that we reached to finish the work. We reached to finish. How can we find the roots of this polynomial to the power 6? It's not easy and it's not difficult. But this depends on your smart mind, your smart thoughts. Okay, if you are so smart, you will see this formula. I didn't see it before. You can see that I didn't see it before, in fact. So, but with Mr. Mourad Sultan Ezouidi, you will involve. I will evolve. Let's say the fields of your field of thinking. Okay. So we told that we summarize. We told that S0 equals 2 equals 4x5, except S1 equal 25 and S3 equal 114. Therefore, your new polynomial that you worked out the values of sk minus 1 can be written as x raised to the power 6 minus S0 of order r, x raised to the power 5 plus S1 of order r, x raised to the power 4 minus S2 of order R x raised to the power 3 plus S3 of order R x squared minus S4 of order R x raised to the power 1 plus S5 of order R equals 0. Therefore, all Sk minus 1 equals 0 except S1 and S3. Means that I'll just make it down if it is possible. Okay. Means that, I'll just write it down. Means that I will use this. Okay. Or I will use all of this. Means what, learners? Means that this is S3, of course, plus S3, this one, Mr. Mourad, plus S3. Okay. 3, of course, here, raised to the power 3, this one, raised to the x raised to the power 2, this is 2. Okay. Okay. Now, this one equals 0 means what, learners? You can see that the C's can be written as the product of two polynomials, 1 raised to the power 2, and the next is, let's say, raised to the power 4, and can be factorized if you want, but no need to factorize with the formula, discriminant formula of Mourad Sultan Ezouidi. You can do it without factorization, because factorization, in fact, is a bad method. Just you will factorize polynomial that you know about the roots that like 1, 2, and something like that. But if you are going, sorry, oh my God, really, I'm very tired. Okay, now we told that our new polynomial has to be written as that, okay, as the product of two polynomial. Therefore, learners, if you want, sorry, I will go back like that, and I'll change the color, maybe blue now. I told now, Mr. Mourad. Okay, like that. It's better. Now go back. Yes. Okay. Yellow. Wow, great. Okay, this is your new polynomial that you got, learners. Therefore, x raised to the power 6 plus s1 of order r raised x raised to the power 4 plus s3 raised to the power of order r raised x squared equals 0 means that you can put x squared as a common factor. This is equal 0. It's clear, and you are going to solve this problem to the power 4. Means x squared is 0, means the xk from 0 to 1 is 0, and x4 plus s1 of order r x squared plus s3 of order r equals 0. Therefore, learners, you can see that x squared is 0 means xk from 0 to 1 is 0. Therefore, or this will imply that alpha, the roots alpha k that belongs to 0, 1 is L0 of ODQ plus xk from 0 to 1 divided by 6, simply because the highest power is 6. It will be 54 plus 0 divided by 6 is 9. Okay, these two roots, two real roots. Now for the next one, I'll just make like that, learners. Okay. I went to blue. Okay. Therefore, learners, we told that the next roots you will suppose that is S1 of order R. We told from the beginning is negative n combination n choose 2. Okay. S1 of order R squared plus 4 times S3 of order R. Okay. Therefore, it will be S1. This is the new discriminant. Okay. That is related to this polynomial. S1 of order R is minus S1 of order R squared plus 4 times S3. This is S3, learners. This is S1. Therefore, you can write S1 of order R dash equal negative 25 squared plus 4 times 114. It will be negative 169. This is a square number, but there is negative sign. So, meaning that this one has to be equal to negative 13 squared. Therefore, minus S1 of order R is equal to 13 squared. So, let's say the value of S minus S1 of order R is positive. Means you will get, let's say, real roots, of course. Okay. Okay, and not necessarily real roots. One positive, next negative. Okay, we'll see like that. No, no, like that. Okay. Therefore, learners, you can see that. I will try to put it down if it is possible. Yes, I can make here the row. Okay. Now, learners, you can see that x squared is 0, or x raised to the power 4 plus s1 of the r x squared plus s3 equals 0 means you are going to use the discriminant to find the S1 that will be derived from the discriminant formula of Mourad Sultan Ezouidi. You will get that is 13 squared. So x squared equal negative S1, okay, negative S1, plus the root of S1 of order R dash, square root, of course, divided by 2. It will be negative 25 plus 13 squared raised to the power half, or root of 13 squared. It will be negative 25 plus 13 divided by 2 gives negative 4. This is x squared equal negative 4. Okay, therefore xk from 0 to 1 is the root of negative 4 exponential ik pi. You can also develop this or explain this minus, it will be minus exponential I pi divided by 2, then it will be as that. 2 root of 4 is 2, and root of minus 1 times exponential ik pi is exponential 2k plus 1 I pi over 2. Means that the roots at k belongs to 0 to 1 is L0 for dq plus xk from 0 to 1. Okay? Of course, this is to 1, of course, Mr. Murad. Okay? Equal 54 plus 2 times exponential 2k plus 1 I pi over 2, all divided by 6. You can simplify more, or you can put it as that, as you like. Okay, go down. This is the first. Now the next, it will be this one. I will change the color so that you can distinguish between the two roots. Okay, green. Here, learners, you see that x squared should be equal to negative s1 of the r minus root of s1 of the r dash divided by 2. It will be negative 25 minus the root of 13 squared divided by 2 gives negative 25, negative 13 divided by 2 gives negative 19. So this is negative because x squared. So we can write as root of negative 19 exponential ik pi, or minus 1 you can write as exponential I pi divided raised to the power half, because root, it would be root xk01 equal root of 19 I pi, which is minus 1 written inside under the square root. Then ik pi, you can write it 2k I pi divided by 2. Okay, therefore here it will be written as root of 19 times root of exponential I pi. Root of exponential I pi, you can write it as exponential I pi over 2 plus 2k I pi over 2 will give you immediately exponential 2k plus 1 divided by 2 I pi. Therefore, the roots of, I label it as alpha, subscript k belongs to 0, 1, is L0 for dq plus what, learners? Okay, sorry, here 1. Okay, plus xk, k belongs to 0, 1 divided by 6. It will be 54 plus root of 19 exponential 2k plus 1 over 2 I pi, all divided by 6. So these are the roots of your new polynomial. Thank you for listening, learners. I'll just make I will save this one. Okay, I just make like that, save. Okay. Okay, sorry for disturbing you. Okay, see you inshallah next time. I will close this one. New journey with Windows. we want to thank you for your loyalty as Windows 10 customer. As end of support for Windows 10 approaches, we are here to support you on your PC journey. Your PC is not eligible to upgrade to Windows 11, no need. Okay, I will close this one, learners. So, our welcome is back. Where, Mr. Murad? Mm-hmm. Where I am. Remind me later. Okay, okay. This. So, thank you for listening, learners. We are here to let you know about my new method. Okay, for solving problem to the power n. Will you can, let's say, watch my channel anytime. Okay, and you are we are here to improve your level in mathematics and to let you practice my own formula, okay, of mathematics, especially in solving problem to the power n, okay, and what else, and I will tell you goodbye and see you inshallah, and goodbye. Okay, I will show you, let's say, one book that I already published it. Okay. hmm This one is okay. Thank you, and goodbye. Close this and stream.